Hey, welcome to this lesson. This is the last lesson on separation techniques. We're going to take a look how to separate solutes from solvents and also how to separate miscible liquids. The first scenario of separating solutes from solvents is um, let's say you're in a situation where you have mixed salt and water, so you want to get your water back or your salt back. So you can use the techniques that we're going to learn because salt is a solute and sorry, and water is a solvent. And the second part, miscible liquids, it's a scenario where you mix two liquids which mix thoroughly, like ethanol and water. Remember, for miscible liquids we use a separating funnel, but for miscible liquids, what can we use? So this is what we're going to study in this video. So we're going to start with the first one, the first technique, which is distillation. So distillation is simply defined as a process of vaporizing a liquid and then condensing the vapor. So in distillation, what you do is you have got, of course, a solute and a solvent, or maybe it can be two liquids. But what the general idea is you heat the mixture, then at a certain temperature, one of the solvent or the solvent is going to evaporate. When it evaporates, it means it has left behind the other component of the mixture, which in that example which I gave of salt and water can be salt. So the water has evaporated. So once the water has evaporated, you can condense it back into a liquid so that you get your water back. Then your solvent is going to remain in the container you were heating. I'm going to illustrate that, so don't worry. The main point is in distillation you evaporate a liquid and then you condense it back to get it. Then the other component of the mixture will remain behind, as you're going to see. So there are two types of distillation that we're going to study. The first one is called simple distillation and is defined as a process used to separate a pure liquid from a solution containing dissolved solids. The example that I gave of salt and water, we can use simple distillation. So we want to get our pure liquid back, and of course we want to leave behind the solid that are dissolved into that solvent. So here is the apparatus for simple distillation. So an example here in this apparatus is a solution of potassium permanganate. So potassium permanganate is just a salt, just like the salt we use, we normally use the edible one, but this one is different. I don't think it's edible. So this is a mixture of potassium permanganate and water. So what you do is you heat the mixture. So as you heat the mixture, the water at 100 degrees Celsius will start boiling, and as it boils, it's going to evaporate. It's going to turn into vapor as a gas. So that will make it move up. As it is moving up, it will go through this tube here. So when it's going through this tube as a gas, something magical is going to happen. So what's that? There's this apparatus here called the Libby condenser. So this Libby condenser, the way it works is there is a continuous flow of water. So water enters here and it comes out here. So there are two tubes here. There's the inner tube here and there's the outer tube here. So our vapor is going to be passing through the inner tube, while this water passes through the outer tube. The function of this water is to make this part of the apparatus cold, or at a temperature lower than the temperature here. Why do we want to have a lower temperature? That's the whole point of having this apparatus here. So the lower temperature is going to make the vapor condense into a liquid. So we are going to have water here, which is going to fall down and be collected in the conical flask. The pure water collected, or the pure solvent collected in the conical flask, is called a distillate. So there are two important things to note. The first one is there is a continuous flow of water, which makes this part a little bit cold for condensation to occur. The second part is the slanting of this apparatus. So slanting, I mean the way it is arranged. This part is higher than this part. Why? So that when the water condenses, it should flow this direction. If you have been asked to draw the apparatus for distillation, and this part you draw it like this, where this part is lower and this part is higher, then it won't give you the results that you want, because as the vapor is rising, and as it passes through the Libby condenser, it will, once it condenses, it will be going back to it will be going back to the mixture. It will be going back to the mixture. Sorry, it will be going back to the mixture and mixing with the potassium permanganate solution. So this is everything about simple distillation. So the next type of distillation, like I said, is fractional distillation. So fractional distillation can be defined as a process of separating a mixture of liquids by distillation using a fractionating column. It is a process of separating a mixture of liquids by distillation using a fractionating column. So fractional distillation doesn't deal with solutes, but it deals with liquids, miscible liquids. So if you have got miscible liquids, you can separate them using fractional distillation. On the apparatus for simple distillation, we add one more thing, which is called the fractionating column. But at the heart of hearts, the arrangement is the same. So this is the apparatus for fractional distillation. So you can see everything is the same. The only difference is this part. So here we've got a thermometer, and here we've got glass beads. So these beads have got a good purpose, as you are going to see, and also the thermometer you're going to see its purpose. So this part is called the fractionating column. So that's the difference between the simple distillation and fractional distillation. So what happens in fractional distillation? So I've got a mixture of liquids here, hot and ethanol, miscible liquids. You cannot separate them using a separating funnel. So as you heat the mixture, ethanol has got a lower boiling point as compared to water. The boiling point of ethanol is about 78 degrees Celsius, and that for water is 100 degrees Celsius. So as you are heating the mixture, the ethanol will evaporate first, since it has a lower boiling point. So as it is evaporating, it will pass through the glass beads. If there's some water which are also evaporating, maybe as the ethanol is evaporating, the temperature of 100 degrees Celsius has been reached, so the water is also evaporating. What's going to happen is the water that is also evaporating, it will only reach here, and it will be condensed back by the glass beads. So the glass beads are able to condense the water, so the water will drop back to the mixture. Well, the ethanol will continue to this stage. The ethanol cannot be condensed back. So that's the function of the glass beads, to condense the water, and their main so as to increase the surface area of the condensation of water. Then the ethanol, once it reaches here, it will go through the Libby condenser. What's the function of the thermometer then? The thermometer is here to monitor the temperature. So if the temperature is 78 degrees Celsius, you'll be able to tell that the vapor here is ethanol. This is just a simple example of having water and ethanol. We can have a situation where we have maybe 5 different types of liquids. So at 78 degrees Celsius, whatever is going to be collected, you are going to know that it's ethanol. At another temperature, whatever is going to be collected, you are going to know that it is another liquid. So that's the role of the thermometer, to monitor the temperature. That's the function. So as the ethanol goes here, the same thing is going to happen as in simple distillation. It's going to be condensed, and we're going to have a pure ethanol here as the distillate. So this is everything about the fractional distillation. Forget about these labels. I was trying to show something, but it's not important. What's important is what I've just mentioned. So the fractional distillation works on 2 physical properties. First, the liquids must be miscible. So always when you want to use fractional distillation, the liquids must be miscible. If they are not miscible, use fractionating column. Then the second physical property is liquids must have different boiling points. So if they are of the same boiling points, then they will evaporate at the same time, they'll condense at the same time. It will still be the mix. At the end of the day, what you achieve is nothing. So you have to make sure that the liquids have a difference in boiling points. So what are some of the applications of simple distillation and fractional distillation? Simple distillations can be used to separate mineral salts from water. So if you have mineral salts dissolved in water, you can use fractional distillation to separate the two. And also the other one, you can use simple distillation to separate the two. Then the other one, which is fractional distillation, it is used to separate crude oil. So crude oil is a mix of different oils: paraffin, diesel, petrol. So they are different oils. So these oils, for them to be separated, we use fractional distillation, because they have different temperatures and they are miscible. So at a certain temperature, one oil is going to evaporate, it's going to be condensed and collected. at another temperature, the second type of ore, just like that. So that's how we use fractional distillation. That's one of the applications of fractional distillation. The next technique that we're going to look at is called chromatography. I like this technique. By the way, for the sake of curiosity, chroma means color and graphy means study. So it's supposed to mean study of colors, but no, don't take that. We're going to study what it is. What is chromatography? So chromatography is a technique for separating mixtures of solutes using a solvent and a separating medium. So chromatography has to do with separating mixtures of solutes. So if you have mixed different solutes together and you cannot tell which is which, the only way you can separate them is to use chromatography. So we do this by using a solvent and a separating medium. There are different types of chromatography. The one that we're going to study is called paper chromatography. In that case, the separating medium is a filter paper and the solvent is always ethanol. So the physical property that makes chromatography possible is solubilities in the same solvent. So the different solutes should be soluble in the same solvent and also should have different solubilities. Having different solubilities means they dissolve at different rates. The other one dissolves more, the other one dissolves less. So that's the physical property for using chromatography. So if you have been given a mixture that has solutes with different solubilities and can dissolve in the same solvent, then you can use chromatography. So we're going to be studying the mixture of dyes. So dyes are coloring agents. They're just pigments that are used to make different coloring agents. So if dyes are mixed, like ink might be made of different dyes. So for us to have, let's say, the blue ink, it is made up of different dyes. So if we have such a situation where we have a solution that is made up of different dyes, we can separate the individual components using chromatography. So here is the apparatus for chromatography. So this is this part, the outer part, is called the tank. So this is the tank. So it's just a tank containing a solvent and a filter paper. So of course the filter paper is this here. So this whole thing here is a filter paper, and on the filter paper we draw a line where we're going to put our sample called the start line. So there's a precaution here. This start line has to be drawn in pencil always. I'm going to explain why. So always make sure that it is drawn in pencil. So then below the start line you need to have a solvent. Always make sure that your solvent is below the start line. Otherwise if your start line is like here, then once you put your samples and you soak your filter paper into this solvent, then your sample is going to dissolve into the solvent. So make sure that your start line is above the solvent. So what happens here? Okay, there are other labels here which I'm going to explain, but for now, let's just concentrate on this part, the solvent. So what happens here? So during chromatography, the science that happens is what happens when let's say you soak a piece of paper, part of it in water, just part of it. What you're going to see is if you remove that piece of paper in water, or if you leave it there, the water will start. The other parts of the paper, the other part of the paper is going to start getting wet, because there will be some of the water moving up. So the other part that you haven't soaked completely is going to be getting wet. Even when you're washing, if part of your whatever you're washing, part of it you put it in water, then you see the other part also just a bit getting wet on its own. So that's the science in chromatography. So what I'm saying is, if you just soak this part of the filter paper here, then the solvent will start the solvent will start going up. In short, this other part is going to start getting wet like this. By the way, you have to put your sample here like this one. So this is a solution that you want to separate. So once you do that, then this is going to happen. Your sample is going to dissolve. So your mixture of sample, the thing that you want to separate, is going to dissolve. So it is part of the solvent. So as this solvent keeps on going up, the mixture or the sample that has dissolved is going to come out. That's what happens. So it's going to come out of it's going to 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 separate out from the solvent, because as you keep on going, the concentration of the solvent reduces. What I mean is, at some point it will definitely stop going. In short, this part is going to be more weight as compared to this part, because there is this solvent here than here. The main point to get from what I'm trying to say is, what has dissolved, all the things that makes up what has dissolved, if they have different solubilities, they are going to separate out from the solvent. They're going to come out of the solvent like this. So let's say this dye which we had put here, which has dissolved, has two dyes. It is made of two dyes. So the two dyes are going to come out like this. So as this continues, the red dye is going to come out and the yellow dye is going to come out. So mean that the original blue dye was made up of the red dye and the yellow dye, but they have separated out. But why is it that this one came out first and this one came out later? It's because they have different solubilities. This one is more soluble than this one. So the less soluble one is going to separate out first, then the more soluble is going to separate out later. So this is the science of chromatography. So you have separated the mixture, which was here, into its individual components. That's the science. So other terminologies, the furthest point the solvent reaches is called a solvent front, and the distance between the start line of your experiment to where the solvent has reached to where the solvent front is called distance traveled by solvent front. And also the distance between the start line and also where the different spot is. For example, the yellow spot, we say distance traveled, distance traveled by spot. In this case, distance traveled by yellow spot. For red, it's somewhere here. So the distance from here to here is called distance traveled by red spot. So these are just terminologies, not really important, but if people are talking about them, or if a question is talking about them, you should be able to tell. So at the end of chromatography, where we see our results, this paper which displays our results is called a chromatogram. So again, terminologies.